Okay. Hello and welcome everyone. My name is Peter Robinson, and today we've got Babu here, or Dr. Babu, who recent PhD graduate, and you're going to talk about your thoughts on MEV and incentivization. So please introduce yourself a bit more and tell us a little bit about your topic, and then please present your slides.
Yeah, as Peter said, I recently finished my PhD in last year. Again, my PhD was not on MEV, my PhD was on cross-chain. And I was looking into some of the security areas of blockchain as we work on blockchain. Then I came across this security issue in this MEV causes some security issues in blockchain. That's how I start looking into MEV. And this is where my research, I just present my research and some of the challenges which I identified as well. So let me share my screen. Yeah, hopefully you can see my screen. Oh, good. Yeah. Okay, just get this to the day. All right. So the name I've given is MEV minimization solution with price guaranteed reward. So we will see the solution which I presented there for a challenge which I identified. That's the reason why this name is like that, right? I'm a lecturer at Southern Coast University, and I do cross research with Griffith University. My PhD supervisors are in there, so I do cross research with Griffith as well. Now, what are we covering today? We will talk about MEV. What is MEV? Try to dive into that. We'll talk about some MEV prevention or minimization solutions. Especially the one I'm interested in is this PBS model. I think that is the one which everybody is sort of working on, the PBS model. Right. Now, within that, there are many research challenges. And one of the research challenges I identified, and I propose an addition to address those research challenges. So that's the topic for today. To get the context going, blockchain transaction flow, a user broadcasts a transaction, it goes to a main pool, and miners pick those transactions, order them, and miners prioritize those transactions based on transaction fee. In a picture form, it looks like that. We have many transactions, 1, 2, 3, 4, with different prices going into this main pool, and miner pick them and prioritize based on the fees, because higher fees goes up, or fees goes down. Is there any problem here, right? No. Okay, that's what we're going to look at. Now, transaction order dependency. Now, blockchain state update with each transaction. Each transaction, the state of the blockchain update, the balance update. Now, there is this token trading and token transfer. This mainly affect in the token trading situation. Now, in blockchain, how token trading happens is through this market maker. So this automated market maker system, where it makes up the market of how much token is worth for the other one. That is where this kind of transaction affects. Now, in simple form, how it works is there is a pool of 2 different type of coins, and it predefines the price of it, right? And based on the balance of these different pools, the price will change. So if there is less on the other side, the price will be higher for it. And so that's how it works. That's called the market makers. I'm not going detail into that one, but the sense of that it is. Now, in that kind of market making situation, if, for example, if a user make a transaction to buy a large amount of tokens, and one other user, so that user makes a transaction based on the price he can predict. So he can sort of see the balance there, see, look, That will be the price of that one, maybe $10 or $5, $6. So that will be the price of that one. He will make that order there. Now, adversaries can see that, or anybody can see that transaction he making, the order that comes in. The adversary simply what he can do is he can buy up that order, that tokens beforehand. So say, for example, in this case, the user put up 4,000 tokens. The adversary can buy up before that other transaction hits. So this is where that ordering of transaction make difference. So the adversary can pay a bit more and make his transaction go first, and he buy all the tokens, or the majority of lot of tokens in that pool. So what's going to happen is when the user's transaction comes in, because there is not much in the pool, users will pay higher fee in there, and the adversary can sell back that at higher fee. So this is where it affects the transaction in the flow. Now there are different type of attacks or different type of form of things out there. The front running, back running, and sandwiching. Right? Front running is where somebody can buy up before you, so they can push their transaction before you, and then they buy up that one. The back running is the other way around. They will sell, once you sell that, they will sell, that drops your price down, and things like that happen. The one we are mainly interested in here is, or we're talking more about here, is sandwich attack, where I send a transaction to buy, say, for example, in this case, transaction 3 is my transaction, which I am buying $1,000 tokens. And this 3 prime is a adversary transaction where he comes and buy before me. That affect the tokens on my price. That means I will pay higher fee because he bought most of the tokens and there is less token in that pool. So I pay high fee, and then straight after that, he will sell his token with that high fee. And this is what he makes. Now, what is MEV? MEV is initially started as minor extractable value. This was originally figured out by miners, and miners were extracting this value because miners can see the transaction in there. Later on, there are a lot of different actors came in, because there are not only miners, anybody can sit there and look for this transaction and they can extract this value. So later on, the acronym changed to maximum extractable value. Recently, I saw a paper, they're talking about blockchain extractable value as well. I think maximum extractable value is a mostly used terminology. MEV is that value, that difference value, a participant can extract within the system being in a privileged position, or in the privileged position by placing the transaction in a order where it benefits them. Now, users, when they send a transaction to the network, especially in this trading scenario, they do not predict, they do not know exact value of the coin. So it may be $5, it may be $10. So they cannot say that exactly, okay, I'm happy to buy this for $5. They can say that, but because of the pool balance situation, when that transaction hit the network, price may be to vary, so their transaction will be invalid. And they still have to pay the transaction fee. So the way it works is, people send transaction to the network, users send transaction to the network, and they will say, look, I'm happy to pay $5 to $10 for this coin, okay? And that is to accommodate the variation in the trading, variation in that thing. This is called slippage. And this is what the MEV. So users create unintentional MEV. This is a part of the trade. They wanted to get this coin, they wanted to buy this, they unintentionally create this MEV. Privileged participant in the network. So as the miners or people can have a full view of the network, they can make profit of this MEV. And it is sort of first come first base, who get it first, they extract it and goes like that. Now, this is the one I got it from the internet. The amount of values that has been extracted from as MEV is a lot. It's a huge amount of value that has been extracted during the last decade. Now, MEV risk and benefits. So what is the risk here? Of course, the first risk is financial loss for users. These are the values which you should be getting, but it is being lost. Now, I should be buying that coin for probably $6 or $7 in the natural market situation, but it has been pushed down to the maximum. So it is that extra money I'm losing, which is somebody else benefiting there. That's a financial loss for users. Consensus instability. So there are situations where there has been MEV sitting in the pass block where miners will dig for that block and then they try to extract the block by reordering the transaction, reordering the block. That is the situation of consensus instability. Validation centralization. Now, the amount of value which extracted through MEV is a lot. It's a huge amount of value. So the miners or the validators can quickly be rich and they can buy up equipments or they can stake and buy up the staking part. So it is a big risk there. Now the benefit part of it is, this kind of trade happens in many networks. So, and all this network have its own way of making the market making value. So if there is in one network, the token value is token pool amount is less, then the value of that is high. And in maybe some other network, it may be high. There is a lot of a lot of token in the pool, so that is less. So in that situation, somebody can buy from the pool. There is a lot more and bring it here. So that actually makes the balance, the market balance. That's a benefit there. So for example, Uniswap and SushiSwap, Arbitrum, OpenShift, that's a good one where the balance, the token price will be balanced between different networks. Now, what is the goal here? We would like to minimize MEV as much as possible. I don't think we can avoid MEV. MEV will be there, but we will try to minimize MEV as much as possible and provide fairness as possible. Fairness is a property where in the context of users in the transaction, but they don't have a say on where their transaction will be landing on. It is decided by the miners. And again, what factors decide that? It is a fee attached to that one. Now, in the MEV case, it's not really the fee. There are two values that the miners try to extract. There is fee, but there is MEV. So in most of the cases, MEV is a large amount, so they will go for that. So we'll see how somehow we can bring the fairness as much as possible. Now, users, as we discussed before, users unintentionally make this MEV, and how can they benefit from the MEV that they generate? Now, one of the proposal for that is called proposal builder separation, PBS model, and this is the architecture where we are separating the block building and the block proposing, the mining part within the core Ethereum protocol. This research is mainly happening on the Ethereum network. Now, what we have previously is we have users and we have miners. So users send transaction to the miners, and the miners pick the transaction, put them in the block, and then they propose the block. These are mainly two actors in the network. In the PBS architecture, we have users and we have a builder. The builder's job is to put together the transactions. They order the transaction in the way it is beneficial for users or builders. That will come to that once. The builders order the block and the proposer propose the block. The way it works is the proposer doesn't know what is builder built at the beginning, and like that it goes. But at a high level, the architecture looks like that. Now, one of the key weaknesses, what we can clearly see here is a builder centralization. The builder can see user's transaction, what is in it, and they can extract MEV there. That's one known limitation or weakness here. Now, to get there, we have gone through many different models, MEV kit, MEV boost, and the previous model. So this is all being done by a research team called Flashbots. As part of their research, they developed separate algorithms and separate client for that one. That's how they done it. Now, getting through this kit model. So users, how does it work is users send a transaction. I think I'm losing some parts here. Okay, I'll explain from here. Now, users send the transaction privately to a relayer, and relayer collect all the transaction, and then they bundle them, right? Now, what is the benefit here is, in before, users send a transaction to the network, the public pool, main pool. So say, for example, if I wanted to buy, say, 1,000 ETH, I send a transaction to the main pool. The whole world can see the transaction. Everybody is after that, I will pay $5 fee, and somebody else will come say, look, I will pay $6 fee, and somebody else come on top of that and $7 fee. It just sort of keep going on. So there were at some point there were transactions, a lot of transaction network. I mean, a lot of transaction network where this kind of war between different people or pods to capture MEVs. In this situation, users are sending this transaction privately to this layer pool, where they can see and they order the transaction in a way that it's partly maybe benefit to user, partly maybe benefit to layer. So they have different actors called searchers will search in that, participate in that, and they extract MEV in there. Okay. Now, and then they send that bundle a order in where transaction go to the miners, and the miners put them in the block. That's why it was started. And when they implemented that, all of a sudden the transaction fees came down, all this congestion came down. It was kind of working. Then after that, they propose this MEV boost, where they introduce another actor called builder in between. So users send a transaction to the builder, and again, the builder will put the block together, and builder will give the block to a relayer, and the relayer will auction that to a validators. This is the proof of stake model. Validators will pick from one of the validators will pick from that relayer, and then they work on that one, right? Now, later on, the PBS model is the current research happening, where the builder will do the same role. The builder will build the block, and builder will auction to the validators. Now, how it works is the builder will build the block, and builder will only reveal the block header to the validator and say, look, I have this block, and this is the value within the block. Do you want it? And the validator will accept or reject. Once the validator accepts the block, the builder will reveal the body to the validator. And from at that point, the validator won't be able to reorder or don't be able to reject the block. That's how the combination is. I just want to skip through this one because there are some actions happening here. Yeah, it is happening. So it is user flashbots. This one is explained here. Now in the current post merge, it was user send it to the builder, and builder and the validator are connected to the layer. Now, any questions so far? We'll come back to that if some possible research direction. The separating the building and the mining, that's a good one. The PBS model, proposed builder separation, makes sense to us in this situation. The builder create the block content and order the block, and the proposer approves the block. That's the one. Now, one important thing for us to understand is the blockchain works in an incentive scheme. Every participant are incentivized to participate in the system. Now, some research challenge in here. We know that the PBS model help in reducing MEV and some fair ordering system. We will be able to achieve that one. But in this model, this builders and the miners, I should change that to proposer. It should be changing. The builder and the proposer need to trust each other. These are the two actors. They should work together in order for the transaction to be approved. So they need to trust each other. Now, the incentive scheme is the weakest one here. Now, I'll explain how the incentive scheme currently proposed is the user send a transaction to the builder, and the builder build the block, and the builder will say to the proposer saying that, look, I got this block, you want this block, and this block has this much value in there. Now the proposer will say, okay, yes, I will take that block, and there is there is a reward for the builder to give the proposer a good block. There is a reward for that. And the builder will, once the proposer accept the block, the builder will release the body to the proposal, and the proposer will propose that block, and then the reward will be paid back to the builder. So this is the adjustment between, or the trust between builder and proposer, where the builder has to trust that the proposal will give them the reward, and the proposer will trust that the builder will give them a good block, and proposer could, that block could contain MEV, could not contain MEV. It's not really predictable that how much it is there. That kind of trust should be there. And in the case of proposer has got a slot in say next slot, and proposer will approach, and a builder approach the proposer saying that he has a block, and the builder will the proposer say, look, I'm going to take this block. Now builder has to release the block very quickly, because the proposal slot is very quickly there. If the builder didn't release the block very fast, as in the time, or delayed, then the proposal actually lost that slot. So in this case, there is no reward for the builder to release the block in there. There could be a delay in there. Now, how can we minimize the trust assumption between different parties in this model? That's what I was looking at. So this is where I thought of having a new price reward scheme to protect the user's interest. Now, technically, when I send a transaction to the network saying that I'm happy to pay 10 to 15 slippage, I'm happy to pay the whole amount. That's technically we are happy to pay the slippage. That's what I was expecting. Now, we can design a system where I'm saying the slippage, but there is a reward for getting a lower slippage. So we need to design a reward scheme. If a user get a minimum slippage, then a percentage of the slippage he's saving will have to go back to the builder. So the PBS model plus price reward can help this this new model. The block builder will get the minimum slippage margin, what he's making, because block builder is the one he's proposing, so he can see what is slippage, where it is, and instead of he try to extract the slippage, he will try to minimize the slippage, where he get, if he minimizes slippage, he will get the percentage. So block builder will get the reward for minimum slippage, and the miner get the reward for transaction fee. So this is all the assumption that all the MEV is being extracted. There is no MEV comes out. It's all being going through this builder model. So the idea is to incentivize block builder to retain the value, the user's interest, and get them the minimum slippage. Now, I'll take you through this one. So users send a transaction. So in this model, what I would see is users have a bigger bigger transaction. So there are many builders, and users can go and ask different builders, look, I have this transaction, how much you are quoting me, right? Some builders say, I got 2% slippage or 3%. The builder will promise a price back to him. The builder can make the promise based on the current price. Builder can see what is in the pool, or he can also see where are different pools, and he have a visibility of what is in there. So, and this transaction could hit in the network in another 2 minutes or 3 minutes. So builder could say, okay, based on all these statistics, this could be the price when it hits. So I can offer this guy this price, okay? And the builder will come back and tell the user, look, I'm happy, I'll give you this much saving on the slippage. And then whatever slippage is saying, you will give me a reward back. So that's arrangement here. So users can go and pick whichever builder, either he go away and pick a builder which he trusts. The builders can make, over time, builders have accumulated trust transactions, and then users will pick those trusted builders. Or users can go and pick the builder which is quoting very less. That's up to the users to decide on that one. Now, once a builder got the block, then he will have different users transaction comes in, and he will build the block, saving, getting maximum saving to the users, and he will build the block. And same way as PBS model currently, he will auction that block to the proposer and saying that I got a block here. Now you want that block. The proposer, there is, as I said before, the proposer builder, there should be a connection between them, not in the way of trust, because the proposer has a slot, the builder has to release a block, and that has to be fast. So there are a lot of builders there, and there are a lot of proposers there. Proposal will pick the builder's block based on some trust assumptions they built, or their the fees what is in there. So the builder will auction that same way before to the proposal. Proposer will pick the block, and once they pick the block, the builder will release the body. That is the time where the proposer can see the body, but he can't do anything. He can't reorder anything. He will put together he will approve the transaction, and all those things happens. And once the transaction is approved, blocks, everything done, then the builder get, based on how much slippage the user saved, the builder get the percentage in that one, and the proposer get the other rewards and everything. Okay, so that's how that model kind of works. Now, there are mainly 3 properties I've identified that kind of addresses this one. Now, block withholding. Now, this was the property I was talking about. The builders can withhold the block, and there was no reward for them to release the block very fast. Because in this model, the builder made a promise to the user based on the current price. Every second count for it. So as soon as a proposer accepts a block, it is builder's interest to push that block to the proposer and get it accepted very fast, because it is based on the price he predicted, and it could change anytime. So there is a push from the builder to get that to done. So there is no incentive for builder to hold back. It is the other way. The builder is pushing that back to be done there. Now, the second property is the trust minimization. Now, in this case, they do not need to trust each other on paying them, right? So builder get its own payment, the proposer get its own payment. They don't need to share any payment. And once the proposer accept a block, if there is no fees, then he may not pay. That none of this drama will be there. Both of them will be paid separately in that one. And lastly, fair ordering. Now, here, users have a say. Users can increase their percentage to say that, look, he can buy the fairness. He can say, look, I'm happy to pay more percentage on the MEV I'm saving. So he is able to buy more fairness in that sense. Now, in conclusion, what we look at is, is MEV good, bad, or illegal? Not sure about that, but there are good part in MEV, there are bad part in MEV. MEV can be, MEV is going to be part of trading system, because that's how a lot of trades are going to work. But MEV exploitation is not really fair. That's not really what we want to do. Now, this PBS model aimed to solve part of that. Now, I think with the price reward scheme attached to the previous model, we'll be able to make the system much more better in the space of MEV. Now, that's all from me.
Yeah, so are there any questions is the thing that you're wondering. And it's always a
yes.
Yeah.
Hello, thank you, Babu, for sharing. I'm Lucky Lau. I'm also doing the same physics, and just started a PhD also in MEV minimization. So well done.
Okay.
Yes.
So I'm sure, because my diving into this different PBS model, not sure I have gone enough, or the things are raised are not how much valid, but I'm happy to get some criticism on that one. If some of the things I say is not really valid.
I'm happy to share some of my thoughts and my research.
Yep.
So one of the things you didn't mention is two things you didn't
You're breaking out.
Mention. One is the MEV smoothing.
MEV smoothing. Is it me or everybody?
Yeah, I can't hear Lucky, unfortunately.
Is to
Lucky, we can't. Lucky,
yeah, Lucky can maybe at the moment we can't really hear you.
Split the profit. Yes, moving the profit. All the where they the profit. Yes, so that they another.
How frustrating. Lucky we had you for a sec there and it was golden. So it had been breaking up, and then it was good. So
I think he's talking about MEV smoothing. I remember I heard about this MEV smoothing thing, but I can't recall what was it. But really interested to look into that.
Yeah. Well, so Lucky, maybe get in contact with me directly, and maybe we can slot you in a month or two's time to present what your literature review has shown, because I know just even in the literature review part of a PhD, you learn a lot and can probably tell us a lot.
Yeah. Ron has put a hands up. Ron?
Hi, yes. I'm just wondering if I'm a miner and I have the alternative of mining the MEV myself and participating in this system. What's the incentive for me to participate in the system?
I think the assumption is here, after some time, you will not be able to, most of the MEV goes through the PBS model, goes through that. So the bigger transaction, all of them will only go through MEV, only go through this proposal builder model, where you will not have MEV lying around in the main pool bigger transaction.
I mean, so you're saying that the users are going to say, I'm not going to send my transactions directly into the mempool.
Yep.
I'm going to go through one of the builders.
Yeah.
Okay.
Yeah, that's what the assumption is. You can throw in the bigger MEV, and that's the same way. People will be fighting for that. It's going to be the same. But the assumption here is if you have a bigger transaction, you will send through some builder.
Okay, thanks.
Yes, Frank.
Yeah, thank you for the talk. So adding builders and miners and so on, it adds another layer of intermediaries, I would say. So
yes,
what is the impact in terms of latency and or resources as well? You share with lots of different people.
Yeah, it is. I don't think it may much difference in there because it's going to be on different layers and everything. So it will be fast. And they're looking at this PBS model to be integrated into the Ethereum in the next one. So this is how it is going. There's no other way we can do with that here.
Okay, and I think we've got Roberto with a question.
Yeah.
Thank you for the talk. I just want to ask, would you be able to explain again why with the MEV price, with the model you propose, the builder has no incentive in withholding the block?
In the in this one, so my understanding is the builder is paid by the validator, or the builder put through the block, and builder is being paid by the validator. So because what we have is only the block, either the fees or the block reward is the incentive which is coming out, right? Now that only will be given to the at the end to the validator. When the validator validates the thing, he will get the fees, he will get the block reward. Then he has to pay back the builder for giving him the block. That's how I understand the payment system works. There is a back payment system works.
Thanks. And why with your proposed model, the builder has no incentive in withholding the block? How do you solve this problem?
Yeah, in my proposed model, the builder has another incentive. So validator, there may be a scheme where validator can pay back, but what I'm morely proposing is, go back to here. In the builder case, the builder will put together the block, right? And builder can see all the MEVs in there, and he will put together the block in such a way that user is going to save MEV. So if I send a transaction to the network, I'm buying 1,000 coins, and then I say, look, I'm okay with 10% slippage, right? And if you save me with 5% slippage, then the 5% I'm saving, within the saving, I'm going to pay you back. I'm going to give you that. So that's included there. So the builder is going to be paid by this savings from the MEV from different users. So and that will be paid to him, and the proposer will get the other proposer, the fees and other things he will get it. Does that make sense?
Yeah. Just another question. So when does the builder get the payment? At which point?
Sorry, say again?
At which point does the builder get the payment?
At which point? So once the transaction is completed, that's the point we know that, okay, this was a slippage at that time, and this was the price, and then that much he saved. So that's at that point there.
And so all of this needs to be baked into the Ethereum layer 1, right? This whole protocol needs to be, it's not something that can be applied on top of Ethereum. It's something that must be embedded into the Ethereum protocol, correct?
Yeah, so wherever this PBS model is going to be embedded, that's where it's going to be embedded. Either can be layer 2 or layer 1. I'm not sure about that at this stage, but wherever this PBS model is going to be embedded, that's where this can go as well. Yes.
That's right. Do you have a paper on this one?
Yes, I do have a paper on that.
If you have the link, you can post in chat.
Yes, please get in touch with me. I'm happy to discuss further from there. Christopher.
Hello, thank you for the talk. Really interesting stuff. You mentioned SushiSwap and Uniswap. I have some experience with those two exchanges, I guess. if the current slippage, standard is like 15%, and you said people are willing to pay that on average, obviously, if they want to be able to buy into these tokens. My experience in particular is with BSC, where there's been plenty of network issues. You've had to set your slippage to 20%, 30%. If this solves that, if this kind of guarantees that they're going to be paying those higher end slippages, would you not just be incentivizing the block builders to add? They're now going to be advertising the slippage percentages, right, with the PBS solution.
Mm-hmm.
Would they not just advertise higher and higher slippages, because they're going to be getting the difference from that? They're going to be making money the higher the slippage is, correct?
Yeah, but they are not making the slippage up, because it's coming from the protocol, right? So they are publishing, but it is coming from the pool. So based on what is in the pool, they're publishing that.
Okay.
So it's whatever is in the pool, they only they can do. So if the pool slippage is high, they can't do much in.
They can't artificially advertise a higher slippage.
They can't advertise. What they can do is they can change the pool coins to make the slippage out, but they can't advertise it because it's coming from the pool, right?
Gotcha.
I don't think you have, in this model, the builder don't have any control on the pool. That's all stays as it is. Yeah.
Okay.
They can reorganize the problem is they can reorganize the transaction so that they can increase the slippage. So the problem with this reward schema is it doesn't really solve the problem in the case of they can get the same reward with or without your reward, because they can, as long as it's the same slippage allowance, the transaction can go through. They can get this by front running. They can change the slippage. They can have the just-in-time liquidity and all sort of this different way. They could still get the reward from the slippage. Doesn't really necessary taking the reward schema. But I do understand. I do understand your approach, and it's similar to my approach. It's introducing a Dutch auction on the price that it's currently doing on the Cal5 protocol Sulfur and the 1-inch fusion order with Sulfur. So I'm currently running both Sulfur and with Sulfur on Cal5 and 1-inch, and that's also will be part of my physics. It's a similar approach, but it is with the Dutch auction that the MEV board no longer attacking the user, but competing to settle the order, and then that way the user can be benefit from the competition that is more broad and can be solve the order on chain with a better slippage. Yeah.
Okay, interested to see. And I also thought about having so builders. There is no nobody stopping the builder from extracting the MEV, but there is one thing could be a possibility is where there is a handful of builders there, and then the builders will eventually build up a credibility. And if I send a transaction to this builder and he saved me a good slippage, then that's where I built the thing. So builders, this kind of credibility builders built, and that will be one point where they get more transactions. So if I build the credibility, I have more transaction coming in, then I don't need to extract MEV. Other way itself, I can build enough profit, profit from that is saving MEV itself. So if I don't have much transaction, then and I only getting less transaction, I will only get percentage from that one. So my intention as a builder is to attract more users and giving them less slippage. That way I have more customers. And more customers means it is better for me because I have a lot of pool of things. So I built the trust there. That was kind of trust model I have thinking about. Right. Any more questions?
Yeah, there were some questions or some discussion in the chat, but I'm not sure if they're answering their own questions a bit.
Yeah. Right. If not, any of these things are not answered, please bring it up. We can discuss.
Why don't you flip to the last slides? Did you integrate those last slides in?
No, I'm sorry, Peter. I couldn't do that.
Okay, I will busily. I'll find them. Don't worry.
I've been put into this. You know, we are participating in this CBDC pilot project with the RBI. So I'm in that committee and I'm heavily into that. So when you send me a reminder, I just thought, oh, we had to do the talk.
Yeah. Well, it's good that you're into the CDBC.
CBDC, yeah.
Helping advise on that.
Definitely, we are in favor of CBDC now because we are working for RBI.
Yeah. All right. Here we go.
Hi, David.
Yeah. So what I'll do.
Hi, Babu.
Hey.
I'll copy that from that computer to this computer. And it's just going to magically work. Start from the beginning. No, that was the wrong one. Start present as view. All right, close that so you don't have to see a whole heap of immutable stuff. All right, share my screen. Oh, and of course, I don't have the sharing access set up. Bummer. Yeah, you know how, all right, open system preferences. Is it going to let me do it? Yeah, all right. And then I'm going to need to race over here. All right, and then it says quit and reopen. All right, so believe me, there are more talks next, but not next week. We've got a week off. And then the following week, we've got Barnaby, who's from Ethereum Foundation. And it's going to be, I think, something like 5 p.m. Brisbane. But it's about PBS as well, but his thoughts on where the future's going with it and what's coming over the horizon. So, Lecky, given you're doing a PhD on this, you might want to catch that one live so you can quiz Barnaby live. And with your obvious interest, Babu, I'd suggest coming along.
Yeah, I send an email I send a message to Lucky, please connect and we can discuss them.
Yeah. And then in 2 weeks' time after that, I'm down for finally getting around to doing my Solidity inline assembler talk and showing you how to jump from one function to another function without doing a function call. So essentially hyperspacing between functions in Solidity. I've only just started a new job. So I've started a job as head of blockchain research at Immutable. So as you can imagine, I'm a bit busy, but I think I'm going to aim to do that because that's like 4 weeks away. So that's heaps of time. Week after that, we've got Philip Zettner from LeFi, and he's going to talk about bridge. So having aggregator bridges. So that's where you've got a bridge and underneath it, you've actually got, say, half a dozen other actual bridges. So not just relying on one bridge. And he's actually going to say that maybe this is what should be used generally and not just, say, for value transfer. So LeFi does value transfer at the moment, but he's going to state the case for just general purpose messaging as well as being part of that. And then we've got Leo Lau, who's going to talk on the 3rd of May about automatic market makers. So he's going to take us, I think, from nothing to multidimensional AMMs and all sorts of really cool stuff. So for those people who like a bit of maths or people who like a bit of DeFi, that will definitely be a good talk. So anyway, Babu, thank you again for delivering a talk. And I reckon you're going to have to be able to come up with a great topic for, I don't know, late 2023 or early 2024 so we can have you on again, yeah. So thank you very much for your talk today. We should all give you a clap. And it's a virtual claps as well. All right. Are there any final questions for Babu before we close the call?
Did you post the link to your paper in the chat?
Okay. There you go.
All right. And I'll put that link into the YouTube notes as well, YouTube description. And Babu, if you can get the PDF version of your slides to me, then I'll be able to post a link to them from the description as well. So
Okay, do that.
All right. Thank you, everyone. Talk to you in 2 weeks' time. Bye-bye.
Thanks, bye.